Dear learners, welcome back to ATS chemistry classes. Today we are going to discuss about UV visible spectroscopy. UV visible spectroscopy is also called as electronic spectroscopy. From the name itself we can say that it's a study of transition that happens at electronic energy level. The electromagnetic radiation used here is UV visible light. Hence it's also called as UV visible spectroscopy. So in order to promote the electrons from one electronic energy level to higher electronic energy level, it needs UV light or visible light. So we have already learnt about the classification of spectroscopy, right? So if you look at my previous videos, you will get the classification of spectroscopy. There also I have explained about the transition that happens between electronic energy level. It's called as the electronic spectroscopy. So if the transition happens within vibrational energy level, then it is called as vibrational spectroscopy. If it happens between rotational energy level, then it is called as rotational energy level. So in this video we are going to discuss about electronic spectroscopy, that is UV visible spectroscopy. In organic chemistry it has wide application. Normally in organic chemistry, UV visible spectrum helps to distinguish conjugated and non-conjugated molecules like alpha, beta unsaturated carbonyl compounds from beta, gamma analogues. Similarly, we can distinguish from homoannular conjugated diene and heteroannular conjugated dienes using UV visible spectroscopy. Okay, let us see what is its principle and selection rule. So there are two absorption laws which govern the absorption of light by the molecule. They are Beer's law and Lambert's law. So together they are called as Beer-Lambert law. Lambert's law states that when a beam of monochromatic light radiation is passed through the homogeneous absorbing medium, the rate of decrease in the intensity of radiation with thickness of absorbing medium is proportional to the intensity of light. Later, Beer-Lambert's law states that when a beam of monochromatic light radiation is passed through a sample, the rate of decrease in the intensity of light radiation with thickness of the absorbing solution is proportional to the intensity of incident radiation as well as the concentration of solution. So based on that, it can be given by the equation minus dI by dx is directly proportional to I into C. So when we integrate this mathematical expression, we get the equation log of I naught by I is equal to absorbance, which is equal to epsilon into C into L. Epsilon is a molar extinction coefficient. Using this equation, we can calculate the concentration of unknown solution. It's required to remember this important equation while solving the questions. If absorbance is given, we can measure the concentration. If we know epsilon and L, L is always 1 centimeter. In most of the cases, C is the concentration which is given in moles per liter. Selection rule. The electronic transitions are governed by certain restrictions called as selection rules. These are: number 1, transition that involves the change in spin quantum number of an electron during the transition is forbidden. That is, they do not occur. For example, singlet to triplet or triplet to singlet transitions are forbidden, whereas singlet to singlet or triplet to triplet is allowed. So next selection rule is that transition between orbitals of different symmetry will not occur. That means n to pi star is forbidden. Similarly, dd transition is forbidden. So these things we have to remember when we are talking about UV visible spectroscopy. Next we will see about the instrumentation. So what is measured in UV visible spectroscopy? So this is the instrument that is used for recording the absorbance of the sample at various wavelengths ranging from 200 to 800 nanometer. Generally, it consists of a light source, monochromator, detector, amplifier and recorded. For generating visible light, tungsten filament lamp is used. For generating UV light, hydrogen deuterium discharge lamp is used. Nowadays, most of the spectrometer that is used are double beam instrument. So the light sources is divided into two beams of equal intensity. These beams are passed through the sample and reference. Normally, solvent is taken in this reference to nullify the absorbance due to the solvent. It's also needed to generate the light of increasing wavelength, that is done by passing it through a rotating prism. You should also know that the sample should be taken in the quartz cuvette, not in the glass cuvette, because glass will also absorb UV light. So glass can be used if the requirement is in visible region. Cell length is always 1 centimeter. So for a known concentrated sample, we can measure the absorbance, that is a log of I naught by I. The plot of absorbance against wavelength will give the UV visible spectrum. Okay, what are the types of electronic transition? Actually, in organic molecule, we will have so many electrons like sigma electron, pi electron, non-bonding electron. So they are lying in different electronic energy level. So they are undergoing transition. So the first one is sigma to sigma star transition. So during the irradiation, if the molecule has electron, sigma electron, then it will be excited to the antibonding sigma star orbital. It is represented as sigma to sigma star transition. All the organic molecules will have this transition. It is observed around 200 nanometer. Energy required for this transition is always the highest. Hence, we are getting around 200 nanometer. The next one is N to sigma star transition. If the molecule has a heteroatom other than carbon and hydrogen, and the heteroatom, if it has a non-bonding electron, then we can expect N to sigma star transition. For example, alcohol, we can expect both sigma to sigma star and N to sigma star transitions. This is also observed around 170 to 175 nanometer. So most of the time we may not observe this because it is the instrument is sensitive only above 200 nanometer. And you should also know that oxygen will absorb in the same region. So it's very difficult to distinguish whether this is due to N to sigma star transition or it is due to the oxygen. Next one is pi to pi star transition. If the organic molecule has pi electron, then when it is irradiated by UV visible light, then the pi electrons will be excited to the anti-bonding pi star orbital. This is called as pi to pi star transition. N to pi star transition. The unsaturated organic molecule, if it has non-bonding electron, then we can also expect N to pi star transition. For example, ketone or aldehydes which will have N to pi star and pi to pi star transitions. If you tell about the energy order, the energy required for sigma to sigma star transition is more. Then comes N to sigma star transition, then pi to pi star transition, then N to pi star transition. N to pi star transition is forbidden and also it is very weak. So what is forbidden transition? So you should, at this moment, you should also know about what is allowed transition and what is forbidden transition. Transition probability, which is denoted by its epsilon max value, that is molar extinction coefficient values. If epsilon max is greater than 10 to the power 4, then that is called as allowed transition. If epsilon max value is less than 10 to the power 4, then it is called as forbidden transition. Benzophenone, for example, pi to pi star transition is observed around 252 nanometer and the corresponding epsilon max value is 20,000, which indicates that it is allowed transition. For the same molecule, we will also get one more band around 325 nanometer. Epsilon max for that band is 180, which is much lower, indicating that it is forbidden transition. Should also know that when we talk about absorption band, so each transition gives rise to an spectral line. So in that case, in the case of UV-Vis spectroscopy, instead of lines, we are getting bands. Why? Because when the molecules are irradiated by UV and visible light, the transition occurs between electronic energy level. It's also accompanied by some vibrational and rotational transitions. Hence, not only one transition is observed, instead we get large number of transitions, which produces collection of spectral lines. So overall, it produces the absorption bands. Next, we also should know about the chromophores and auxochromes. Chromophore. In Greek, chrom means color, phores means carriers. So they are color carriers. It is defined as any isolated covalently bonded group that shows characteristics absorption in the UV or visible regions. Example, nitrobenzene. Nitro group is a chromophore for nitro compound. Next one is auxochrome. In Greek, oxo means increase, chrome means color. So it increases the color. So from the name itself, you can say that it is to increase the color. So this can be defined as any group which does not itself act as a chromophore, but whose presence brings about a shift of absorption band towards the red end of the spectrum. For example, nitrobenzene, it's a yellow in color. So if you check about para-nitrophenol, para-nitro or ortho-nitro, aniline, so they are orange or red in color. The yellow color is due to the nitro group, and OH or NH2, they enhance the color to orange or red. Similarly, if you take this azobenzene, so that shows lambda max at 320 and the corresponding epsilon max value is 21,000. So whereas if you have ethoxy group at para position, so that is para ethoxyazobenzene, so that shows lambda max at 385, so it is shifted to longer wavelength. So the corresponding epsilon max value is 42,000. So intensity is also increased. So we also have some other terminology to mention about the absorbent bands. So if the absorption band, if it is shifted to the right side, that means higher wavelength side, then it is called as bathochromic shift, also called as red shift. If the absorption band is shifted to left side, is called as hypsochromic shift. It is also called as blue shift because it is moved to shorter wavelength. So sometimes the band will be shifted to higher intensity range. If its lambda max is same but epsilon max is increased, the intensity is increased, then it is called as hyperchromic shift. If the intensity is decreased, that means epsilon max value is decreased, then it is called as hypochromic shift. So I would also like to say about its application. Most of the time UV-Vis spectroscopy is used to distinguish the isolated and conjugated double bonds, especially in organic chemistry. For structural elucidation, we use lambda max value to distinguish the conjugated and non-conjugated double bonds. It's also used to measure the concentration of any inorganic or organic molecules, or even it's useful for measuring the concentration of biomolecules like proteins, DNA and RNA, etc. It's also so helpful to follow the chemical reactions and also enzymatic reactions. So with this, I wind up this session. In the next session, we will discuss about the lambda max calculation. Until then, thank you all. Happy learning.